In today's video, we are going to be looking at the inverse normal distribution. Now, the word inverse means opposite to. So if we think of inverse operations, the inverse of adding is subtracting, the inverse of dividing is multiplying, the inverse of squaring is taking the square root, etc. Recall in the last lesson, we looked at the normal distribution where we used it to find specific probabilities. With the inverse normal distribution, we are given probabilities and asked to find a value of k, which gives a specific area under the curve. And the area under the curve represents the probability of an observation taking a certain range of values. So let's take a look at an example. In example 1, we have a random variable x that's distributed normally with a mean of 100 and a standard deviation of 5. In part A, we need to find the value of k such that the area to the left of k gives 0.9 or 90%. So here we are going to go into our distribution menu. So second, distribution, choose option 3, the inverse normal. We are going to enter 0.9 for area. Our mean is 100. Our standard deviation is 5, and we are going to select left tail since the area that's being shaded is to the left of our value k. Paste the value, and we get an answer of 106 rounded to 3 significant figures. Okay, so here are the calculator steps on the screen and our final answer. Part B. Find the value of k such that the area to the right of k is 0.37. Again, go into your distribution menu, select inverse normal. This time we're going to change our area to 0.37. Our mean and standard deviation are unchanged. We will select right tail and paste our value. And we obtain a value of k of 102 if we round to 3 sig figs. And again, here are the calculator steps. Now, it's very important to note that you do not want to write your solutions using calculator notation. You can write this on the side to show the examiner or your teacher what steps you use to figure this out, and you might get some method marks, but you never want to answer as inverse norm, bracket, 0.37, et cetera, et cetera. Okay, so this is just the calculator's way of entering the inputs. You want to communicate your solutions effectively. Example 2. Your teacher determines that no more than 80% of this year's class should pass the final examination. The examination results were approximately normally distributed with a mean of 62 and a standard deviation of 13. Find the lowest score necessary to pass the examination. We'll start by defining our random variable x to represent the examination scores. We know that x is normally distributed with a mean of 62 and a standard deviation of 13. Here is a useful diagram to illustrate the situation. Our normal curve is here. We know the mean score is 62, and somewhere to the left of 62 is a passing score. The area under the curve to the right of the passing score represents 80% of all the scorers. So we're asked to find a value of k such that when x is greater than or equal to k, the probability or the area under the curve is 0.8. Now let's go into our calculator. We will select second distribution to go into our distribution menu, inverse normal, enter an area of 0.8. Our mean is 62. Our standard deviation is 13. Here we need to select the right tail, paste our value, and we obtain a k value of 51.1. Here are those GDC steps. And finally, the lowest score to pass is going to be, we'll round up to 52 since we're assuming that the teacher will not assign part marks, so we want integer values only.